let's try this. This is question number 21 from this worksheet. Question number 21. Let's try this. Okay. The second part of this, we want to focus on this basically. When a has this value, so we'll find that value from the first part. We need to show that f of x, this function, is never negative. So we'll see how to think about problems like these. Okay. Let's do the first part first because we don't have the value of a. Let's start from the first part for that reason. We've got a polynomial that's f of x. F of x equals x raised to power 4 minus 2x cube minus 2x square plus a. That is a polynomial that we've got. And we're given that this function is divisible by, what does that mean? Divisible by, that means this thing is a factor. It's divisible by x squared minus 4x plus 4. This is a factor, x squared minus 4x plus 4. Okay. Given this, we need to find the value of a first. That's the first thing we've got to do. Now, what can we do? Can we use the remainder theorem here? Remember, what was the condition for remainder theorem? Remainder theorem only works when the divisor is linear. In this case, the divisor is not linear. Okay, so the first thing that should come to your mind would be that you can't use the remainder theorem here, at least directly. You'll have to use long division. Okay, even synthetic division doesn't work here because the divisor is not linear. So you'll have to do long division in this case. Okay, so you can do long division, and after you're done with that long division, you get a remainder at the end. You'll put that remainder equal to 0, and that's going to give you the value for a. That's one possibility. But if you think about it, there's actually a quicker way of doing this, and we can actually change the divisor in a way in this particular question that it becomes linear, or we can actually find the linear factors for these divisors. We can't make this linear, but we can actually split it further into its linear factors, because if you think, this is something that we can actually break the middle term for. We can do middle term breaking here. This can become x squared minus 2x plus 4. And that gives us x into x minus 2, minus 2 into x minus 2. So we get two factors from that, which are x minus 2 and x minus 2. X minus 2 and x minus 2. So we've got a linear factor now that x minus 2 is also a factor of this. So we could write it as x minus 2 whole square as well. Some of you might be able to recognize that this is actually the form a square minus 2ab plus b square as well. So if you wanted, if you were able to figure that out, you could write this directly like this as well, x minus 2 whole square. But if not, you can just do middle term breaking like we did here and split it into two linear factors. Okay. Now, if this was a factor, x minus 2, which is something linear, this should also be a factor. This should also be a factor. Does that make sense? Just like if you had 24 and you knew that 8 is a factor of 24, right? 8 is a factor of 24. Now, any factor of 8 that you can find further, for example, 2 and 4, these are also factors of 24, right? So factors of 8 are also factors of 24. That's the same thing that we're doing here. We are factorizing this further, and that's giving us x minus 2. Since x squared minus 4x plus 4 is a factor of this polynomial, these linear factors, they should also be factors of this polynomial. So in this particular question, we could actually find linear factor x minus 2. Now, once we know that, we know that we can use the remainder theorem here as well. Okay, so x minus 2 is a factor. We know that. So what value of x do we input here? We put this equal to 0, x minus 2 equals 0. We get value of x equals 2. We put this value of x in that function, and that gives us f of 2 equal to 2 raised to power 4 minus 2 into 2 raised to power 3 minus 2 into 2 squared plus a. Now, since x minus 2 is a factor, this remainder should be equal to 0. So we put this equal to 0. We get 16 minus 8 plus a, and the value of a turns out to be 8. So you were saved from that long division process. You could just do this directly like this. All right, Suleiman, yes, that's correct. You can still use long division as well, and that will work. That's going to be slightly longer, but that will also work. So you just have to divide this polynomial by x squared minus 4x plus 4. Find the remainder. That will be in terms of a. You put that remainder equal to 0, and that should give you the same result as well. So that should also work. All right, let's look at the second part now. Now it says when a has this value, show that f of x is never negative. Now, what is the polynomial? The polynomial is f of x equal to x raised to power 4 minus 2x cubed minus 2x squared plus a, which is 8 in this case. This is what the polynomial is. You need to show that this function is never negative. Now, what does that mean? That means its graph, whatever that is always above the x-axis. If this is the x-axis, the graph always have to remain above the x-axis. It can't come down, right? That's what we need to show, that this function never has a negative value. It could touch the x-axis. Yes, that is possible. That it just touches the x-axis like this. But it can't go below the x-axis. It cannot be negative. All right, that's what you're being asked to show. Now, the problem is we don't really know anything about quartic functions. We don't know much about power 4 functions. We don't know how their graphs look like. We don't know what their turning points look like. We don't know much about this function. So as we do for solving equations, we break such polynomials down to smaller factors. We'll do something similar here, so it's easier for us to understand. We would want to convert it to quadratic or linear factors, okay? Because then we would be able to understand what's happening to this function better. Right now, we can't because we don't know anything about power 4 functions, all right? So we know one factor already. We know that x squared minus 4x plus 4 is a factor. How do you find the other factor? You do division for that. And as it turns out, actually, it would have been better in this case that you had done long division in the first part, because you need to do that in the second part anyway. All right, but we did not know that before. If you had read the second part already, you would have figured out that you need to do long division for the second part. So it would have saved you time if you did it for the first part as well, because then you could just use that result from there. But anyway, we have to do this now. Let's do this. We need to divide x raised to power 4 minus 2x cubed minus 2x squared. Remember, the x term is missing. So that's 0x plus 8. We need to divide this thing by this factor and find the other factor that's going to come in the quotient. X squared minus 4x plus 4. Let's divide it by that. X squared minus 4x plus 4. Okay, let's do this division. What do we multiply x squared by to get x raised to power 4? We multiply by x squared, x squared into this whole thing. That gives us x raised to power 4 minus 4x cubed plus 4x squared. Now change the signs. This becomes minus, plus, minus. This gets cancelled, and we have 2x cubed minus 2x cubed plus 4x cubed. That's 2x cubed. Minus 2x squared minus 4x squared. That's minus 6x squared. Then you have 0x plus 8. What do you multiply x squared by to get 2x cubed? You multiply it by 2x. 2x into this whole thing now. That's 2x cubed minus 8x squared plus 8x. Again, change the signs. This becomes minus, plus, minus. This gets cancelled. And we have 2x squared minus 8x plus 8. What do we multiply x squared by to get 2x squared? Multiplied by 2. 2 into that whole thing, that's 2x squared minus 8x plus 8. Everything is cancelled, and you get a remainder of 0. That confirms that your working is correct because you're getting 0 remainder. This was a factor. You should have got 0 remainder. But what's the other factor now? The other factor is this. X squared plus 2x plus 2. So that function that you had in the beginning, f of x, that can actually be written in factorized form like this. X squared minus 4x plus 4 multiplied by x squared plus 2x plus 2. These are the factors that we've got for that polynomial, for that function. Okay. Now, these are functions that you know about. You know about these two functions. You know how they look like. These are quadratic functions, right? This and this. This was something that you did not know anything about. So we have simplified it a bit in that sense. Now, what we have to do is we have to show that this f of x is never negative. We have to show that this is never negative. How do we do this? We look at each of these functions separately and we think about what they look like. Never negative could be that we have one of these, we have both of these positive. So this is also positive and this is also positive. That could be one way of getting a positive result. Another way could be that both are always negative, because that would then give us minus into minus. The result is going to be positive, right? So it could be one of these two things, most likely. Let's try to think about both of these functions. These are both quadratic functions. Let's see how they look like, how their graph looks like. Okay, so all of you, I'm assuming, know quadratics. What is the graph of this function? How does this look like? It's a U-shaped graph. It's a U-shaped graph and it looks like this. What about the second graph? This is also a U-shaped graph. This also looks like this. Now, how do we know whether these functions are positive or negative or both? We don't know where the x-axis is. It could be here. In this case, the upper part is positive, the lower part is negative. It could be here. In this case, it's just touching 0. So it could be 0 or positive. Or the x-axis could be below here. In that case, this whole curve is always positive. It could be any of these cases, right? How do you figure out which one of these cases it's going to be? You look at the turning point. Remember, how did we used to find range of quadratic functions? We used to think about the turning point of the graph. That's what we do here. We find the turning point of both graphs. Find the turning point of this graph and also of this graph. Now, there are a number of different ways of doing that. You could complete the square for both of them. You could use minus b over 2a, whatever you prefer. I'm going to use minus b over 2a for both of them one by one. Let me do that for the first function. X equals minus b over 2a, right? That's what I'm doing to find the x coordinate of the turning point. Now for the first thing here, I'm going to get minus b, that's minus 1 to minus 4 divided by 2 times 1. And this turns out to be 4 over 2, that's 2. What about the corresponding y coordinate? Put this back in this function, x squared minus 4x plus 4. That's 2 squared minus 4 into 2 plus 4. What do we get from this? This gives us 0. So that means the turning point of this function is 2 and 0. All right. So where's the x-axis going to be? It's going to be like this. This graph is just touching the x-axis. It's never negative. It can either be 0 when it touches the x-axis. It's equal to 0 at this point, or it's something positive. That's what we have found from this reasoning. Okay. Let's look at the other factor now and think about what's happening to that factor. So this, we have figured out this is 0 or positive. Okay, this could be either 0 because it's just touching the x-axis, or it could be 0, that means it's positive. It could be positive. Let's look at the other factor, x squared plus 2x plus 2. Let's do the same thing on that as well. X equals minus b over 2h, so that's minus 2 over 2 times 1. That gives us x equals minus 1. Put this back in this expression. That's y equals x squared, that's minus 1 squared, plus 2 into minus 1, plus 2, and that gives us y equal to 1 minus 2 plus 2, that is 1. So this turning point is minus 1 and 1. Where's the x-axis going to be for this? You see the y coordinate is 1. That means it's something positive, right? We look at the y value to figure out the value of the function. In this case, since the y value is positive, that means x-axis is going to be below this. Okay, so this whole function is going to be above the x-axis like this. It's always positive. Okay, so what we have figured out is this is what the function was. F of x equals x squared minus 4x plus 4 into x squared plus 2x plus 2. This is what it was, right? What we have done is we have found the minimum point of both functions. Minimum value of this function, what's this? It's 0 for this function. Remember, when we talk about minimum or maximum value, we're talking about the y value. Minimum value for this function is 0. Minimum value for the second function is 1. For the second function, the minimum value is 1. Now, if you multiply a number that's greater than 0, greater than or equal to 0, by a number that is greater than or equal to 1, what is the result going to be? The result is also going to be greater than or equal to 0. You cannot have a negative result. That means it's never negative. What's the working that you'll have to show for this? You'll have to first factorize. This is the important thing. You show the two factors, and then you say, then you just find the turning point somehow. You find that the minimum point for the first factor is 0, and the minimum point for the minimum value for the second factor is 1. So the product can also not be negative. It also has to be greater than or equal to 0. And that proves that f of x is never negative. Does that make sense? This is slightly tricky. This the slightly trickier part of this topic as compared to the other concepts that we've done. All you have to do is whatever polynomial you have, you're going to break it down into factors first. Okay, so mostly it's going to be quadratic and linear factors. Then you think about that quadratic factor. What does its graph look like? You look at the turning point, and then give your reasoning based on that turning point. You could have, so in this case, it says prove that it's never negative. You could have other similar problems like this. They could ask you to prove that something is never positive, or something is always positive or always negative, things like that. You use exactly the same method for all of them. You factorize first, and once you've factorized, you look at the turning points of the quadratic function and then reason based on that. Is this clear to everyone? Any questions? Make sense? Uh, Zoya, you're right about the first one. You're right about the first one. You could write this as x minus 2 whole squared. So this is a square. We know it cannot be negative. Yes, it works for the first one, but this is not x plus 1 whole square. This is x plus 1 whole square plus 1. Okay. And that is something that we have to do completing square for. So if you can figure that out, or if you can do this mentally, some people are able to do that, that they are able to write this thing directly like this. So if you are one of them, then you could do it. You could say you've got a square plus 1, so that's why this is also positive. So the product is also going to be positive. Okay. But that's only in this particular question, right? So this is the general method that we've done that will work in every such question. Okay. So this being a perfect square is just specific to this problem, right? You might not have a perfect square in another problem. So for that, you'll have to do this. You'll have to use the turning point thing. And similarly for this, in this case, it's quite easy to figure out that this is x plus 1 whole square plus 1. But in another function, you might have to do the whole completing square process to convert it to a form like this, and that would be more complicated. So this is a standard thing that you can use. Just find the turning point, and then based on that turning point, argue that the whole thing is going to be either positive or negative, whatever the question is asking for.